Today, in this video lecture, we will see shear force diagram and bending moment diagram of this overhang beam. First, understand this beam. See, total length of this beam is 5 plus 2.5 plus 5 plus 2.5. That means 15 meter total length of this beam. Understand loading acting on this beam. For that A to C portion, 10 kN per meter uniformly distributed load acts on this 5 meter length. At point C, 100 km downward load. At point D, 50 km downward load. And for this B portion, 50 kN per meter uniformly distributed load acts on this 2.5 meter distance. A is hinge support, B is roller support. Now, let's draw free body diagram of this beam. What is free body diagram? Free body diagram, that means remove support and give reaction. This is hinge support. That means draw free body diagram here. Remove this support and draw reaction. This vertical is AY. For hinge support, two reaction, vertical and horizontal, and X. Now remove this roller support also. And for roller support only vertical reaction, BY. So this is free body diagram of this beam. Now judge shear force diagram of this beam. Before that, understand deflection of this beam. This beam deflect like this. That means for that B portion, it is like this. And for A to B portion, it is downward. Think this deflection shape is like this. See, more load on 100 kN, 50 kN, 10 kN meter is on AB span of this beam, and this B is also, so correct deflection is like this. So this B is like this. That means hogging. That means this portion B is hogging moment because deflection is like this shape. And this portion A to B, this AB portion is like this deflection. That means sagging moment occurs on this AB portion. So now just shear force diagram. This AY is vertical. So this shear force at A goes upward. Between A to C there is UDL. So UDL, that means inclined line. So this is like this incline. At point C, 100 kN downward. That's why shear force is downward. Between C to D no load, that means horizontal line. At point D there is downward load, so shear force diagram is downward. Between D to B there is no load, so this is also horizontal line, and BY is vertical. So BY is upward. B to E there is also UDL. So this is like this. This UDL is like this. Positive, negative, positive. So this is judgmental shear force diagram. We will calculate exact values and exact shape later. This is my judgment only. So this 10 kN per meter, this 100 kN and this 50 kN is near to this point A. So more load is shift towards point A. So as per my judgment is maximum here, and this AY reaction is maximum. So for now calculate bending moment. This is SFD. Now calculate bending moment. So at point A there is hinge support, that means zero moment. Between A to C portion there is UDL, so parabolic curve. So this is like this. C to D there is no load, so inclined line. D to B also no load, so again inclined line. And B also UDL, that means parabolic line. And why I draw between this B to E portion downward negative bending moment? Because deflection of this BE portion is hogging. That's why hogging moment generates. Hogging, that means negative. So what is maximum bending moment? Where is understand loading and CG of loading. This 10 kN per meter, this 100, this 50, and this 15. So this 10 into 5 is 15 somewhere here. Convert this UDL into concentrated load. 15, 10 into 5, 50. kilonewton, and this 15 into 2.5, 37.5 kilonewton. So 50, 100, 150, and this is 5 meter. Total is 15 meter. So here, because CG of load is somewhere here. Now let's solve this. First we will calculate reactions. Vertical force positive and downward force negative. See free body diagram. AY and BY vertical, 50, 100, 50, 37.5 downward. AY is vertical, BY is also vertical. 50 is downward, that's why minus sign. Minus 50, minus 100, again minus 50, and minus 37.5 equal to 0. So AY plus BY is equal to 50, 100, 37.5 plus 50, it is 237.5. Unit is kilonewton. We had not calculated this AX because there is not any force for equilibrium to X direction. This AX is equal to 0. That means axial force diagram is 0 here. Now calculate AY or BY between both of these. How to calculate AY or BY? For that, take moment. So take moment at this point A, or you will take moment at this point B. So moment at point A is equal to this C. We will calculate moment at this point, A point. So we will go from left hand side to right hand side and see forces. This 50 kilonewton is clockwise to that point A. Clockwise, that means positive. So 50 into, and distance is, this distance is 5 by 2, because see, this 10 kilonewton per meter load is uniformly distributed load, acts on this AC portion, and we had converted this 10 kilonewton per liter load into point load, and for that we will multiplication of this UDL and this 5 meter distance, and this acts on center of this beam. So center of this beam is 2.5 meter from point A. So 50 into 2.5 positive because of clockwise. Again, see this 100 is also clockwise to that point A. So plus clockwise, that means positive. 100 is force into perpendicular distance is this between 100 kilonewton and point A. So it is 5. Again, this 50 is also clockwise to that point A. So again, this 50 positive because of clockwise, force is 50 multiplied by perpendicular distance is 5 plus 7.5. 50 into 7.5. Now see this force. This is also clockwise to that point A. Clockwise, that means positive. Force is 37.5 multiplied by perpendicular distance is total this 2.5 upon 2, and this 5 plus 5 10 plus 2.5, that means 12.5 plus 2.5 upon 2. So this is 1515.625. So something see, again consider this force also, minus by into 1515.625 minus by into this 5 plus 5 10, this 5 plus this 5 10 plus 2.5 12.5, and equal to 0, minus because of this is anti-clockwise to that point A. So let's calculate this. So this by comes 121.25. Now put this by in ay, in this equation 1. So ay is equal to 237.5 minus 121.25 equal to 116.25 kilonewton. So this ay is 116.25 kilonewton and by is 121.25 kilonewton. Now next step is to calculate shear force diagram. This 116.25 kilonewton is nothing but the reaction. See here, 116.25 kilonewton. This is, and shear force calculation. First is shear force at point A equal to 116.25 kilonewton. Now calculate shear force just left to that point C. So shear force C just left to that. For that, see, this reaction is upward and this force is goes downward. So upward is positive and downward is negative. So positive AY minus 50. And AY is 116.25 minus 50 equal to 66.25 kilonewton. So next is shear force at this point C, just right to that point C. So up to here, see, shear is this 66.25. Now consider this 100 kilonewton. So this 66.25 is positive and this 100 kilonewton is downward, that's why negative. Positive 66.25, 100 kilonewton is downward, that's why negative. So 66.25 minus 100 is minus 33.75 kilonewton. So our judgmental SFD is correct. Here it is 33.75. Now between C to D portion there is no load. So here see this D and just left to that D, same load, same this 33.75 load comes, because in between there is no load. So shear force at D just left to that D is shear force just left to that D is similar, minus 33.75, because in between C to D there is no any load. Now again see this D point. See this D point and just right to that D point shear force. So at D this 33.75 is also, but see this 50 kilonewton is downward, negative. So minus 33.75 minus 50. Shear force at D, CRC left. This is D. Here it is D. So right is minus 33.75 and is downward 50. That means minus 50. Upward is positive, downward is negative. So minus 33.75 minus 50 is minus 83.75. Kilonewton. Now next see this. Next see this B point. See, just left to that B shear force is similar to this minus 83.75 because here shear is minus 83.75 and in between this no load. So shear force at B just left is minus 83.75. Now next shear force just right to that B is, see, at B shear is this 83.75 and just right, that means this By reaction also comes and this By is upward, that means positive. So minus 83.75 plus positive By, minus 83.75 plus 1 to 1.25. So it is 37.25 kilonewton. So here shear is 37.25 kilonewton, just right to that point B. Now calculate shear force at this point T and just left to that point T. Shear force just left to that point E. So up to here shear is 37.25 and this 37.5 is negative. So positive 37.25 minus 37.5 equal to it is 0 kilonewton. So my judgmental shear force diagram is slightly wrong. See, this is not like this, this is not like this, this is at cantilever it is 0. So yes, 116.25, 66.25, 36, 33.75, 83.75, 37.5 and 0. Yes, now it is correct. We will see this in StatPro software also. So now next step is to calculate bending moment values. So bending moment at a 0 because of hinge support. At hinge there is only two reaction comes, vertical reaction AY and AX. See free body diagram, red color AY and AX are two reactions only, there is no movements. So movement at point A is 0, and at point B see red color vertical reaction BY, there is also in roller support only vertical reaction comes, so horizontal reaction and movement is 0 there. So at B and A movement is 0. Bending moment at A is equal to 0 and bending moment at B is equal to 0. Now our work is to calculate maximum bending moment, this maximum bending moment, and where maximum bending moment occurs, at which point, at that point maximum bending moment occurs where shear force is 0, and here see shear force is 0 at a distance x from point A, because we don't know number of exact number of that x. So for that, consider this beam. This is AY reaction. This is uniformly distributed load, and this distance is let's shear is see shear is 0 at a distance of 5 meter. So just put 5. Just calculate movement at this C point, because from A 5 meter distance, that means this C point, this C point. So this AY is, we will calculate moment at this C point. So AY is clockwise to that C point. So positive 116.25 clockwise, that means positive 116.25 into 5, because this is 5 meter distance. This AY is vertical, this is 5 meter distance. So again this 50 is downward and clockwise to that C. So anti-clockwise. So anti-clockwise, that means minus, load is 50 and this distance is 2.5. So multiply 2.5. So and equal to, so 456.25 is maximum bending moment. This is 456.25. Unit is kilonewton meter. So bending moment at C is equal to 456.25 kilonewton meter. Let's understand how we calculate movement. For movement, we multiply force into perpendicular distance. For shear, we sum or subtract vertical and downward and vertical forces. So let's understand this properly. Here B is here. So next, calculate bending moment at point B. Now bending moment at point B is B, that means at this point. So for calculation of bending moment, I will consider this portion and calculate bending moment from right to left. So see this bending moment at B is equal to 0. Consider this portion By and UDL. By reaction vertical, uniformly distributed load 15 kN per meter. I not take this 37.5 because I consider this 50 kN per meter. Either you consider UDL or conversion of UDL into point load. Don't take these two loads. This 37.5 is only for representative purpose. So right to left, we will calculate movement. So when you calculate movement from right to left, if movement comes positive, then change sign of that movement. If movement comes negative, then change sign. So we will consider positive sign convention. This is positive shear and this is positive movement. So this and this like this. This is Vx, this is Mx, and we will calculate bending moment at this point. So for that point, Mx is anti-clockwise. So minus Mx, clockwise is positive, anti-clockwise is negative, plus By into x. This distance is x. No, we know this distance, right? We know this distance is 2.5 meter. So write directly this distance. Don't write x. 2.5 meter. So By into 2.5 meter, and By is 1 to 1.25. 1 to 1.25 into 2.5 meter. Again, this 50 kilonewton per meter is anti-clockwise to that point. So minus 15 into 2.5 is concentrated point load, and this concentrated point load is acts at middle of this beam. That means 2.5 by 2 and equal to 0. So this Mx is equal to 121.25 into 2.5 minus 15 into 2.5 into 2.5 by 2 equal to 0. So it is 256.25. Something is happened at By there is. See how our calculation is wrong. Our need is to calculate bending moment here at this point, because see this is cantilever end and it is cantilever, it is zero moment at here, and for moment calculation at this point we need to consider all this side beam. Here we only consider this portion, so that's why our calculation is wrong. So see, only movement point is this movement point is here. So this mx is anti-clockwise, that means minus. It is correct. So it is correct. This 15.25 into 2.5, this is plus, because now it is clockwise. This by is by reaction is 0 because it goes through this point, because perpendicular distance is 0 there. So this mx is, and this vx, solve it again. See, this is see this is like this movement is like this is vx, this is mx, and we need to calculate movement at this point. So this mx is positive because it is clockwise. This 15 kilonewton is 15 into 2.5. This is concentrated point load acts on this beam and at a distance of 2.5 by 2. So this is correct. So mx is equal to 15 into 2.5 into 2.5 by 2. It is 46.875. And remember this, change sign. So this is minus. So here moment is minus 46.875 kilonewton. Now let's see in StatPro software. For 'new' metric, create. Zero. Total length of this beam is 12.5 plus 2.5. That means 15 meter. From from node 0, second node is 12.5 and third node is 12.5. That means total distance is, see, utilities, node tools, node to node distance, total distance is 15 meter. So go to geometry, add beam, give beam. So this is only line model. Now go to properties, define, we define some section don't need to define section, but for this TADPRO errorless analysis we need to provide some section. So 230 by 450 section and assign to you. If we don't define this section, then STAD don't give us moment and shear values, because error comes. But here we only calculate bending moments for live load, so we don't calculate bending moments for dead load. So don't our values are correct for dead load. SFD BMD is matches with us manual calculation. Now support, one is pin support at point A. So select this, use cursor to assign here. Click Shift K for node scene purpose. Again fixed but create roller support. In roller support only FY reaction comes and all other are releases. So click on this MX, MY, FZ, FY releases. Support 3, use cursor to assign. So supports. Now next is loading. Load case details. Add live load. Add close. Click on live load. Click on add and click on member load. Then uniform force. Type here minus because this load is downward. Minus, that means load is downward, and positive, that means load is upward. See here I see direction GY, and GY is see here GY is upward, but direction GY and W1 is minus, that means this is downward. And load is 10 kN per meter. So and this is 5 meter. So D2 distance is 5 meter. Add, close, click that load, use cursor to assign this. So next is 100 kN load at point C. Again add, click on live load, add member load, click on member load, click on concentrated force, minus 100 kN, add, but minus 100 where distance is 5 meter. See here 5 meter from A. Add, close, use cursor to assign this. Now next is at point D, it is 50 kN and D point is 7.5 meter from point A. So again D1 is 5. See this diagram. D1 is 5 and D2 is 0. Change. So it is correctly applied. Again, edit. D2 is 0. See this diagram. Because there is this load is not eccentric, and this is, and D1 is 7.5. So change. Okay. Now next is 50 kilonewton per meter load. This BE portion. 15 minus kiloton per meter. Add loads. Click on that load. Click on member. Assign to selected beams. Assign. Yes. So our loading is now correctly applied. So let's analysis it. Define command. Add loads and run analysis. We will see how shape of bending moment and shear forces is. For live load only, not for dead load. So see deflection. See how deflection occurs. Next is FZ, that means shear. See this shear shape. See our shear shape matches with that. Let's see this line, white shows incline. Okay, here white is incline. I don't. Let's see values. Annotate close. 116.25, 66.25, 33.75, 37.5. That means it is correct. Now see movement. STAD shows hugging movement as positive and sagging movement as negative. STAD shows hugging movement as positive and sagging movement as negative. And in our manual calculation, positive movement is sagging and negative movement is hugging in manual. So this STAD Pro movement is inverted than our manually calculation movement, but values are similar. Only signs are different. So it is 449, and see here shear bending at a distance of 5 meter, 456.249. Yes, it is correct. And at a distance of 12.5 meter, it is 46.